In the first two examples, we used the Pythagorean theorem to solve a missing side of a triangle. So we were told that these triangles were right triangles. Therefore, we knew the Pythagorean theorem applied, and we used it to find the missing side. Now, we're using the Pythagorean theorem differently. This is called the converse of the Pythagorean theorem. It is in reverse. So now, they're giving us three sides of a triangle, and they're asking us to answer the question, is it a right triangle? Well, if we think this through logically, if a squared plus b squared equals c squared, using these three sides, then we know that we have found ourselves a right triangle. So, once again, how do we start? Writing out the Pythagorean theorem. Now we have to label each of these sides. We know the longest side is always c. The other two can be interchangeable. It doesn't matter. So let me put those into my formula. So I've got 5 squared plus 12 squared equals 13 squared. Well, I know that 5 squared, 5 times 5, is 25. I know 12 times 12 is 144. And I know that 13 squared is 169. So, does 25 plus 144 equal 169? Well, it does in this case. 169 does equal 169. So we know that, yes, we do have a right triangle. So once again, because the Pythagorean theorem does work, because both sides of the equation are equal, then 5, 12, and 13 must make up a right triangle. Let's do one more example. Same approach. We are given sides 3, 4, and 6. We know that the longest side, 6, has to be C, the hypotenuse. The other ones we can label. It doesn't matter which way. So if I substitute these values into the equation, I have 3 squared plus 4 squared equals 6 squared. Well, I know that 3 squared is 9. I know that 4 squared is 16. And I know that 6 squared is 36. Well, what does 9 plus 12 equal? That's 25. Well, does 25 equal 36? No, it doesn't. So we put that line through the equal sign, showing that it does not equal. So because both sides of this equation do not equal, we know that these are not a right triangle. They may form a triangle, but it is not a right triangle because the Pythagorean theorem doesn't work with its sides. Go ahead and try these examples, the got it's. I think it's in the middle of the page.